Hello there, Algebra 2B, and welcome to Lesson 8.5. Here we are going to be solving rational equations, added, subtracted, divided, multiplied. Now solving equations, and it's really not too bad. We are going to need to check for extraneous solutions once more, but let's just begin by looking at a good old problem here. So last lesson we talked about common denominators. That is going to be very important again, that we are going to need common denominators in all fractions that you see. So this time we have three fractions. Don't let it scare you. Ideally, let's have the least common denominator, but let's make these all in terms of 2 and p. So notice that these already have a p with them, the second and third fraction. They already have a p, so instead, or not instead, all we have to add is a factor of 2. So I'm going to multiply the first fraction by 2 over 2, the second fraction to 2 over 2, and you'll see I'm just going to write down everything here, minus 2 over p equals 1 over 2p. And then as you do that, we end up with the same denominators. Now just be careful, this is a quantity, so we're going to want to distribute. So 2p minus 10 minus, this is 2 times 2, 4. Okay, this is the first fraction, this is the second so far. All over 2p, all over 2p, and is equal to 1 over 2p. Okay, don't reduce anything because it'll just take you back to the beginning. But we are going to now add like terms. So I distributed this negative, so you can think of it as adding a negative 4. So really it's 2p minus 14 all over 2p and 1 over 2p on the left. And once we have these things, so once we have the denominators the same, okay, that makes us happy. Essentially, you can kind of pretend like they're not there. They can just poof, disappear. And we can think of this as 1 is equal to 2p minus 14. So when the denominators are the same, they can kind of cancel out. That's essentially what happens. The reason why is because we'd end up cross-multiplying, and then they would cancel anyway. Okay, so when the denominators are the same, just imagine they're not there. And it makes it nice. Then we just have our numerator. 1 is equal to 2p minus 14. We solve for p. Okay, so we're just going to add 14 over and add 14. That's 15 is equal to 2p. And we'll divide by 2. And then all that is 15 halves. It's okay to have a fraction, so 15 over 2 is the answer. Now it is a good idea to check, okay? I would recommend just doing it all in your calculator. So when I plug in 15 halves, 1 divided by parentheses 2, another set of parentheses, 15 divided by 2, and hit enter, I end up with, no, it's a fraction, 1/15. So 1 over 15 is that equal to, and again, it's all about parentheses with these fractions, 15 halves in parentheses minus 5 divided by 15 halves, which is a third, minus 2 divided by 15 divided by 2, 4/15, and 1/3 minus 4/15 is equal to, look at that, 1/15. So it does work out. For the most part, they will not be extraneous. But so just to recollect all that, make sure you have common denominators. Once you do, the denominators kind of disappear. Oof, this is just a cloud. And then you can solve like an original problem. Most of them will not have extraneous solutions, but you can just check in your calculator. Okay, so a lot to bite off, but let's just look at another example. Okay, number 2 here. So really the only thing this first fraction is missing is a 5. So this is 5r squared, r squared. So I'm just going to multiply by 5 over 5, this first fraction. And that makes it, so remember to distribute 5r plus 10 all over 5r squared. And that's equal to 6r. They're already like terms, so, or common denominators are already alike. So I'm just going to add right off the bat the common terms. Okay, all over 5r squared. Denominators are the same, so they can just kind of cancel or disappear. That then leaves you with 5r plus 10 is equal to 6r minus 9. And it's just a regular old solving problem from there. Minus 5r is r minus 9 equals 10. We'll add 9 over. And 19 is equal to r. Okay, that one should work out as well. You can also check in your calculator. I'll leave that up to you to do that one. Okay. Number 3. So hopefully you're kind of realizing first common denominators. Now this is a p squared, this is a p squared, this is a 5p. So it's kind of like finding in a puzzle what each one's missing. The first fraction is missing a 5, so I'm going to, rather the second fraction, multiply it by a 5 over a 5. The last fraction is missing, so we have a p squared. It needs another factor of p, so I'm going to multiply this one by p over p. When you do that, so the first fraction already has everything. The next fraction, 1 times 5, is just 5. And then our denominator will come out to be the same. Second fraction, so minus 6p all over 5p squared. Adding like terms, so 5 minus 6p all over 5p squared is equal to 1 over 5p squared. Denominators are the same, so they can disappear. And we'll just set it equal. 1 is equal to 5 minus 6p. We'll subtract 5. So negative 4 is equal to negative 6p. Divide by negative 6, divide by negative 6. P is then equal to 2/3. Okay, so don't be afraid of fractions as answers. That will likely happen a lot since we are already dealing with fractions. But they're just numbers too. So just be comfortable with fractions as such. Again, you can double check that one works out as well. So 4x squared. The only thing that's missing is a 4. So 4 over 4 to the last fraction. Again, distribute. So 4x minus 4 all over 4x squared. That would be that fraction. Middle fraction, nothing needs to happen to it. And last fraction, nothing needs to happen to it either. Combining like terms on the right hand side here. So 5 plus negative 4 is 1, so it's 4x plus 1 over 4x squared. Goes x plus 5, 4x squared. Denominators, the same, so x plus 5 is equal to 4x plus 1. And I'm going to subtract the x to keep it positive, and then take a -1 to the other side, and x is then equal to 4/3. Alrighty, and check that one out. So last few, again, really the same idea. Practice makes perfect with these. So 1 over x over 3x. This one needs a factor of x, so I just multiplied by x over x. This fraction is going to need a 3, so 3 over 3. And the LCM is 3x, so it doesn't need anything else. 5x minus 5 over 3x. Plus distribute. Don't forget distribute. Distribute. Okay, that's where a lot of students will make mistakes. Over 9, over 3x. Boo, boo, boo. Add our like terms. 13x minus 9. All over 3x. Again, you don't add the denominators, so to speak. They just stay the same. 5x minus 5 over 3x. Poof. The denominators can disappear like a magic trick. So 5x minus 5 is equal to 13x minus 9. Let's subtract the 5x. 13 minus 5 is 8. Sometimes my mental math needs to wake up too, so just double check. All right. 8x minus 9 is equal to -5 plus 9 plus 9. -5 plus 9, I do know that one, but positive 4 is equal to 8x divided by 8. X equals 4 over 8, 1/2. Again, I'll just show you the check for this one. So I'd like to do it piece by piece. So I got x equals 1/2. 5x minus 5, so 5 times 1/2 minus 5, so that's the numerator, divided by 3 times 1/2, and it would even be a good idea to just absolutely everything put in parentheses. Okay, so I get -5/3. Is that equal to 1/3? So I can actually keep that one. Plus, I'm going to double parentheses 4 times the quantity 1/2 minus 3 divided by 1/2. Boom, boom. I got another set. Oh, too many parentheses. And hey, I get the same thing, -5/3. Okay, so it can be tricky to do that. Use a calculator. It's a lot to do in your head. Number 6. So 6a, 6a, 3a. Really, so what we want to do is make them all the same denominators. So I could make it 18, but instead, let's just make this 3 into a 6. So we'll just multiply by 2 over 2. So then we have a plus 5 plus 1, so really just a plus 6 over 6a equals 2 over 6a. Denominator is the same, so a plus 6 equals 2. Subtract 6, and a equals -4. Okay, so great job. This stuff can be tricky, I know. And I know you're like, I'm never going to use this. And there are not many not practical, but ready applications at your stage of mathematics. But just keep in mind, it's a big world. You never know what you'll go into in the future. And it really builds your mathematics skills for some later things if you take higher level math. So adding, subtracting, multiplying, and now solving rational equations. Great job. Do your best, and have a great day.